A solenoid having inductance 4 Henry and resistance 10 ohm is connected to a battery of 4 volt. In the first part, we have to calculate the time constant. We have time constant as L by R. Substituting the value L as 4, resistance is 10, so I have 0.4 second. That is my answer for the first part. In second part, we need the time elapsed before the current reaches 0.63 of its steady state value. Now one thing is clear, that we have inductance, we have resistance, a battery is connected to it, so obviously charging will take place of the inductance. Fine. And in case of charging, we know that the current in the circuit is given by I is equal to I naught 1 minus e to the power minus t by tau, where I naught is the peak current. Now we had to calculate the time at which the current reaches 0.63 times of steady state value. This steady state value is nothing but the peak current which is acquired at the steady state. So I is 0.63 times of I naught is equal to I naught 1 minus e to the power minus t. We have to calculate the time t divided by L, I mean tau, which is given by 0.4. So we have I naught cancelled, so e to the power minus t by 0.4. This term comes over here, 0.6 comes over here. We have 1 minus 0.63, that comes out to be 0.37 e to the power minus t by 0.4. Taking natural log on the both side, we have minus t by 0.4 is equal to natural log of 0.37. So on solving this equation, I get the value of t as 0.4 second. That is my answer. In C part, I have to calculate the power delivered by the battery. We know power delivered by the battery is given by VI, where V is the voltage of the battery definitely, and I is the current flowing through the battery. So we have to calculate the current first, because at that very instant we don't know the current. So I is equal to I naught 1 minus e to the power minus t by tau. Fine. Now we know the time because we calculated it in the previous part. So I naught, that is we have to calculate, I naught is the peak current. Fine, that is 0.4, that is R by V. Obviously we know we have to calculate the instantaneous current, so that will be 1 minus point E minus 0.4 by tau, that is again 0.4. So on solving this, I get the value of current I as 0.25 amperes. So substituting this current in this equation, I have power as V, that is 4, into current, that is 0.25, that gives power equal to 1 watt. In D part, we have to calculate the power dissipated in form of heat. So obviously in form of heat, energy is dissipated only through the resistor. So power will be calculated by I square R. This is the energy dissipated through the resistor in the form of heat. I know the current, that is 0.25 whole square. Resistance is given as 10, right? So on solving this, I get the value of power as 0.64 watt. That is the answer.